All right, my friends, if you are still here, it means that you want to figure out how to set up HTTPS support on your Kubernetes cluster. Now, the first thing I want to mention to you, and I want to make sure this is really clear, is that in order to set this stuff up, you are going to have to purchase a domain name, which is about $10 US, although sometimes you can find ones for a little bit cheaper than that. So this is a required step. You have to have a domain name, either one already purchased, or you have to buy one to use with your cluster. Now, the second thing I want to mention is that you and I are going to go through the process of setting up HTTPS, but we're not going to talk very much about TLS or HTTPS or certificates or anything like that. There's a ton of resources out there online already for you to understand exactly what HTTPS is doing for us and the benefit of applying it to any given web application. So with that in mind, let's talk about the overall process of how all this stuff is going to work. All right. So we're going to set up a little bit of interaction between our Kubernetes cluster and a certificate authority called Let's Encrypt. I suspect you've probably heard of Let's Encrypt. If you haven't before, essentially it's a service that allows us to get free certificates. All we have to do is set up a little bit of communication between our Kubernetes cluster and a Let's Encrypt service. So here's the sequence of actions that are going to be going on behind the scenes. You and I are not going to actually see these steps occur. We're going to kind of peripherally see them occur, but essentially what we're going to be doing for setup is creating some infrastructure to allow these steps to happen. But again, you and I aren't going to very directly see these things occur. So the first thing that's going to happen is our Kubernetes cluster is going to issue a request to Let's Encrypt, and it's going to say, hey, I own a domain called multik8s.com, and I need a certificate from you, Let's Encrypt, that says that I do in fact own that domain. And once we get that certificate, we can then use it to set up HTTPS that is going to be widely supported or recognized by any given browser, such as Chrome, Internet Explorer, whatever it might be. In response, Let's Encrypt is going to immediate reply and say, you own multik8s.com? I don't believe that. I don't believe it for a second. But I'll tell you what, I'll give you the benefit of the doubt. If you, Kubernetes cluster, really do own the domain multik8s.com, I'm going to make a request to multik8s.com /well-known/random string of numbers right here. If you really own that domain, then you will reply with some information that I expect to hear from you. So essentially what's going on right here is Let's Encrypt wants to make sure that you and I really truly own this domain. So it's going to tell us that it's going to make a request to some route, like this right here. And if we truly own this domain, you and I are going to set up a route handler that's going to reply on specifically this route right here with some information that is provided to us by Let's Encrypt. So that is something that is very challenging for us to fake. If we said that we own something like, Google.com, and Let's Encrypt replied in the same fashion and said, okay, well, if you really own Google.com, I'm going to make a request to Google.com / this random route right here. Chances are you and I are not going to be able to manipulate Google's infrastructure to get the appropriate response to that route. So that's how this authentication process is essentially going to go down. Let's Encrypt is then going to make a request to that route. And then as long as our Kubernetes cluster responds with the appropriate data, Let's Encrypt is going to say, oh, okay, you know what? I guess you do own this domain. So I'll tell you what, you check out, you own the domain, so I'm going to give you a certificate that's going to be good for 90 days. And after that period, or when that time is about to elapse, you're going to have to go through the same process all over again. So in some number of days, you're going to have to come back to me and ask for another certificate and claim that you own the domain multik8s.com. So as long as we set up some infrastructure to handle this, we'll get our certificate and we'll be good to go. Now, to give you a little bit more behind the scenes here of what you and I actually have to do. You and I are not going to set up any route handlers to facilitate this process. You and I are not going to be making any request over to Let's Encrypt. We are not going to do any of that stuff whatsoever. Instead, we're going to set up another little plugin through the use of Helm. Remember, we installed Helm just a little bit ago. We're going to use Helm to install something into our cluster that's going to automatically facilitate this process for us. So we're going to install something into our cluster that's going to automatically reach out to Let's Encrypt. It's going to say that we own some particular domain. It's going to automatically set up a route handler to respond on this route. It's going to then automatically get a certificate back from Let's Encrypt, it's going to save it into a secret and make it available to the rest of our application. And then after some amount of time elapses and the add-on decides that it's time to renew the certificate, it's going to automatically go through this process again. So the challenge for you and me is not setting up like this stuff right here. It's setting up the infrastructure to do this stuff for us automatically. That's the challenge. That's what we need to do. So with that in mind, let's take a quick pause right now. We're going to come back to the next section and we're going to start going through this setup, starting first with purchasing a domain. So quick pause and I'll see you in just a minute.